Hello and welcome back. So here we have a fidget spinner and we need to calculate the force required to overcome the 20 Newton resistance force. So to do this, we will apply sum of moments about the middle of the fidget spinner, which is right there. So we've got three forces. We've got the 20 Newton force, which will create a moment about that point. We have the horizontal component of the Q force and the vertical component of the Q force. Okay, so breaking Q up into its horizontal and vertical components. So we've got its horizontal going this way and we've got its vertical component going that way. And we can place this horizontal component here, since that's the point of application. So there's my right angle here. This is 60 degrees. So the horizontal component will be Q cos 60 and the vertical component will be Q sine 60. Now if I extend the line of action, this will be the distance that I need, the perpendicular distance. And for the vertical component, if I extend this line of action, I will need this perpendicular distance right here. Now since it's drawn to scale, if we get a ruler and measure this distance here, you'll find this to be 24 millimeters. And if you measure this distance here, you'll find that this will be 29 millimeters. So now applying sum of moments about the middle of the bearing. So sum of moments, we'll call that O. So let's put that O there, is equal to 0. We'll assume anti-clockwise as positive. So I've got the horizontal component, which is Q cos 60, times its perpendicular distance, which is 29 millimeters. I'm going to convert that to meters, so 0.029 meters. And that's going clockwise, so that's a negative. And then I've got its vertical component, which is also going clockwise, so that's minus Q sine 60 times its perpendicular distance, which is 24 millimeters, so that's 0.024 meters. And now I've also got this 20 Newton force, which is going to be positive 20 because it's going in an anti-clockwise direction. And its perpendicular distance from this force will be the radius of this smaller circle. Now the diameter is 10, so the radius will be 5. So convert the 5 millimeters to meters, which is 0.005, and that's all equal to 0. So now chuck the Q's to the other side and factorize the Q's out. So we get Q, open bracket, 0.029 cos 60 plus 0.024 sine 60 equals to 0.1, which is what 20 times 0.005 is. Divide both sides by 0.029 cos 60 plus 0.024 sine 60. So plug that into the calculator. We can cross these two out and we get Q is equal to 2.83 newtons. So the key to this question is separating the Q into its horizontal and vertical forces, and know that this is drawn to scale, so we can just use our ruler and measure our perpendicular distances to the middle of that bearing. Sum the moments up, equate it to 0, and you'll find your Q force.